All right. Hey everybody, so we're doing another unscheduled Go component lab. This one is actually not really specific to Go, which is why it's not part of the main schedule, but you might be interested if you're into TypeScript, as well as kind of the rest of the stuff that I've been doing. If you're watching this after the fact on YouTube, well, if you're watching it live on YouTube, be sure to go to Twitch so that you can chat and ask questions. If you're watching it afterwards on YouTube, definitely leave comments. Let me know what you think, or if you have questions, or any feedback at all is appreciated. Yeah, so one of the things that I wanted to do, I'm trying to put together a kind of diagram of how all the pieces are coming together, because all these streams are basically working on pieces of a project, which are pieces of a bigger project, which are pieces of a bigger project. And so I thought it would be interesting to kind of visualize that so people can kind of see where everything fits in. So today we're focusing on this little piece because we're basically starting from the bottom up here. We actually have qmux in Go. I wrote it over the weekend. Is pretty much just a subset of the crypto SSH library. So it's basically taking just the pieces that pertain to the spec that I wrote to get, which itself came from the SSH spec. Let's see here, which is in the repo. Again, everything I'm doing is in the my prototypes repo for now. And this has evolved while actually implementing it. I had to bring back some of the open confirmation and failure stuff. Even though you don't have to accept manually or reject like you did with the SSH library, it'll automatically do open confirmation, or if something's wrong, it'll fail. So this has been updated to reflect the implementation that I wrote here. And again, not wrote, but kind of massaged. There's a lot of copy and paste and getting rid of the irrelevant stuff. And kind of organizing it into a simpler thing. It's just over 900 lines. I'm wondering if we can simplify it even more. A lot of this stuff has to do with the flow control stuff, which isn't that complicated, but it's just sort of like there's code that has to be written. You know, a lot of it has to do with you know, allowing concurrency and stuff like that. So there's a bunch of locks and conditions. One of the things I'm not sure about, and maybe somebody else can kind of tell me, ask on Twitter, they have that it's not uncommon to have like a read buffer from a connection, but in this case, and it has partly to do with the window, because well, maybe not the read buffer, the write buffer, which is an actual bytes buffer. Is it? No, it's actually just a bytes thing. Anyway, for the read buffer, they actually created a custom linked list of bytes. And it seems like for the most part it operates like a bytes buffer. So I'm curious if anybody can tell me why they think the crypto SSH authors did this. Because I'd love to, even though it's not that much, I'd love to, if possible, replace it with a bytes buffer. Anyway, so I implemented this, and it actually wasn't that hard to get it from just like writing the code to, there was only a couple of things wrong when I just dropped it into our demo, our qRPC demo. So we actually have it wrapped up in here. And qmux is intended for things like WebSocket, but you can obviously use it for TCP, really any kind of stream. because it's a very lightweight binary transport for muxing, and so I haven't tried it over WebSocket, but I'm assuming it's going to work. But here's a version where it basically wraps a TCP connection, and our demo just worked, just like it did with SSH and Quick and Muxadoo. So that's cool. The only thing, I mean, eventually we're going to have to write this in, because this is this. So besides being I think personally, multiplex connections is sort of the way of the future. It's sort of like when you realize what lightweight threads are and how that changes your way of thinking about concurrency and programming. I think the same with multiplex connections, because they can basically act like connections, but they're free and you can just send them all over the same pipe. And with stuff like Quick coming out soon, it's just out of the box, and companies like Google have sort of already determined the sort of cost savings efficiencies of multiplexing. But I've been into multiplexing ever since Local Tunnel, just the kinds of things that you can do with it and the things that you can model. And gRPC is another great example of like how you can use the semantics of connections in a multiplex hard connection or real connection to simplify protocols. So I think it's a great building block for protocols, and so that's why qRPC is built on top of or requires a multiplexed protocol, which is why, you know, we have this abstraction here and a bunch of different transports. The only thing is if we port qRPC to JavaScript, which would probably be in TypeScript, it would need to work, you know, ideally with WebSocket. So, or whatever language, it will have to have some kind of multiplexing. And there definitely aren't a lot of, you know, HTTP2. Most of those libraries are not exposing the lower level framing stuff like Muxadoo has. SSH, again, there aren't often that many good libraries, and it, you know, pretty heavyweight. Quick is getting there. Like, there is a good native implementation in Go, luckily. There aren't a lot of other good native implementations in other languages. Some that are trying to wrap the libquick, the official Quick library that Google is working on. I imagine Quick will eventually come to every language, just because the nature of it is, I do think of it as sort of like the protocol of the future. And in the meantime, we have qmux, and so qmux is, you know, the whole point is it's incredibly simple. The only complexity comes from the flow control stuff, but I think it's a good stopgap, a good general purpose like multiplexing, a way for people to get kind of comfortable and used to the idea of multiplexing. So the idea is eventually I need to port it to every language that I want to support. But the first one, the most important one, is JavaScript. So that's what we're going to do here, and we'll see how far we can get in about an hour. So we can do kind of a quick overview. There's only 7 types of messages in qmux. Open, 2 different kinds of confirmations, a window adjust message that's basically sent with every data packet, an EOF for closing right, and then close, which actually sends, when you get a close, you're supposed to send back a close to sort of close properly. There's a couple of constants here that are not specific to the protocol, but have to be specified. And so these were just copied from SSH, which are also copied from OpenSSH's implementation for window size, packet size. There's also, I guess, a minimum packet length. I think that's used in, I don't know where that's used. It might be used for the data message, because that's the only one that actually has kind of an arbitrary length. Basically, its last byte is the size of the rest. You know, very common prefix length definition. This is just kind of an internal, there's some channels used here, and I guess they set a buffer size here. So this is, I guess, you know, how many simultaneous incoming connections before they're processed, before things start to block. There's some constants on when you define a channel, and I'm not sure how useful this is. We might be able to remove this, is determining whether your channel representation is the outbound channel that opened or the inbound channel that was accepted. And we have some structs, and they're all pretty simple. They're all just a bunch of uints, basically. The only one that doesn't have a uint is the data one. And this actually mirrors the packet, doing a binary encoding of these, prefixed with a single byte that represents the message type, which is defined by these constants. So define some interfaces up front, which basically look like our transport interface, and so that's why we can kind of just drop this in. We have a session that wraps a connection. And I'm almost wondering if this should be something that would work with any read-write closer as opposed to a connection, in which case we might drop local adder and remote adder, assuming that you can grab the connection underneath to get local adder and remote adder. And again, like we've talked about, those basically give you a way to open channels or accept channels. Like that's the top level interface besides close and wait. And wait, by the way, is because an actual closed connection is going to have that two-way close. So it'll actually wait until it gets that close. Then we have a channel, which, you know, looks like a read-write closer with a close write. And then we implement an ID just because that's part of our interface. SSH didn't expose that, but they do have an ID, so we just expose that internal thing. So here's our session struct. When we wrap a connection, we have a kind of a helper below that's a channel list, and so this manages the IDs and reuses IDs and stuff like that. We have incoming channels, which is basically because we have a loop that will read messages, and then once, you know, a channel is established, it'll throw it in incoming channels. So accept just listens on incoming channels. It's pretty simple. And then because there's an asynchronous loop that could return an error, it sets the error and has an error condition. And this is what wait is based on. So you can kind of see this here. There's some helpers here. Send message does a marshal and a write. So marshal and unmarshal at the end, which I'm not sure if they actually need to be exported, but there would actually go from structs to bytes or bytes to structs. So that just lets us work with structs in the rest of it, which I don't know if that buys us a whole lot, but it's at least a little bit more readable. And like I said, wait is based on this error condition. And this is the loop. So once you connect, whenever you create a new session, you get this to run. And so this is kind of interesting. It will loop over one packet, and one packet both reads and processes a packet. And if there's an error, then it sets error and the error ends, and then we basically close all channels, close the connection, and set the error and broadcast on our condition. This is something that I wrote because normally SSH would read from their lower level sort of encrypted transport where it says ReadPacket. And so normally they would have a reference to their, the transport layer underneath that does all the encryption stuff. So I replaced that with my own ReadPacket, which is a lot simpler. This is where it's basically reading the protocol, right? It reads 1 byte to see which message it is. Based on what message it is, we know what the size of it is, so we get the rest of the message. If it's a channel, if it's a data message, then we look at the size and we grab the rest of that, and then we return the bytes. So that's ReadPacket. One packet will then go and process it, and it kind of does basically two different things. There's sort of this global, there's only one message that's kind of non-channel specific, and that's open. So if it's an open, we handle the open. Otherwise, we assume it's a channel packet. So we parse the channel out, we get the channel object, and then we actually have the channel handle the packet from there. So we hand it off to the channel. On open, this is our handle open. We unmarshal it because we're handed the bytes to get the channel open message. This is the only way you would get a failure, is if your max packet size stuff is different than the settings, than the constants here. So that's actually pretty rare if you're using this library with itself, but when you have different implementations, that's where this comes in. Otherwise, we set up a channel, we send it to incoming channels, and send the confirmation. And this is where it differs from SSH, where SSH, crypto SSH, you would actually have to accept the connection for it to send back the confirmation. Here, we just accept, we confirm all of them as long as they are the right size or whatever. Accept right here is basically just listening on incoming channels. You'd think we'd have something, maybe we can, I don't know, listen on the condition that we have so that we can return an error if the connection closes, obviously, so that's a little to do. If anybody wants to go in and do that, that'd be cool. And then your high level open. So if you want to establish outgoing open, we do kind of the same thing. Set up an open message, send the message, wait to hear back. If it's confirmed, then we return the channel. If it's failure, then we say that it failed on the other side. We simplified the failure. There used to be like a failure code and a message and an encoding, and I didn't feel like that was necessary because you don't have that when you open actual TCP connections. Web Constantine, qmux. You can check out the spec here on my program prototypes repository to kind of see. It's just a multiplexing library. Sorry, I didn't see your message before. And if we get any other message, then we return error. So this is all pretty simple. Channel gets a little bit more complicated. We store the IDs, the remote ID and the local ID. Every channel has an ID on both sides. We have our max payload and remote payload settings, which either come from a constant or the other side, depending on which one it is. A reference back to the session. We have direction, which I'm not sure how, really how this is used. It seems like it's just used for This is kind of a sanity check. It's only really used when you get a connection response message received if the direction if you're getting a response message and then this is run when you I think open, and so it's saying if it's inbound, but of course this is outbound. So I don't know. This is something that was in the original, and I think there might be some reason with the rest of the protocol of SSH that would have been necessary, but it might not be necessary here. So again, there's a lot of other stuff here. We have a channel for, you know, channel messages, basically those two responses. We have some flags for whether you send an EOF that's basically used for, again, sanity checking, sent close. I think those are just to protect methods from being called again. We have a representation of our window, the remote window, which we manage with this window struct later on. And then this is this buffer that's a linked list of bytes, and I'm not sure why it's not a bytes buffer. But that's how they implemented it. If we could simplify it, that would be cool. But there might have been a reason for it. This is your window size. There's a mutex on it. There's a mutex on write for channel. And this used to be a map because there used to be different types of data that you could write on a channel, right? Because SSH you could do standard out or standard error, but you could actually do other things as well. And so this used to be a map, so they'd have one for every extended code or whatever. Here it's just a byte array for the, you know, and this is used for writing because flow control wise, if you've used up the window, it's got to basically keep that somewhere until it can write again. So writing a packet on the channel, it does some mutex stuff. It checks to see if closed, you know, this kind of stuff. It sets close if you're sending a close message. Send message looks like the send message on session. We marshal it. Though we always kind of insert the remote ID before we write the packet. This is a helper that this is kind of more convenient. It's only used once, I guess, right here. Just because of this kind of type conversions and stuff like that, it is actually a little bit cleaner to do it as a function. But that's what SSH did too. So this is their write on a channel. You can see it does some protection stuff. It grabs the write buffer. Does the whole window thing where it tries to reserve space, and it'll block if it, you know, it doesn't. It'll wait until it can write. Blah 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 blah. It sends the data, and then it, whatever the packet is, it sets it and locks it. So whenever we get data, it goes through handle data, and so this goes through a process of checking to make sure that, you know, if it's greater than payload, does some sanity checks, checks it against the local window, and then it writes it to this that pending linked list buffer, because then we have a read method that basically pulls off of that. But again, I'm not sure why it's not a bytes buffer. And we have a window, which is actually a helper that's mostly used on read. So read just looks in that linked list buffer and we'll adjust the window. So for every read, it basically sends an adjust window. I didn't realize that about SSH, but that's how they do flow control. Close, a bunch of closed stuff. So it's interesting once you get into just like a little bit of, you know, thread safety and, you know, some flags and stuff, how complicated these methods. I mean, this isn't complicated, but like there's a bit going on there. Again, this is called when you get an inbound message. This is actually what handles the packet on a channel. And it kind of checks it in two ways. For these first couple of messages, it actually checks the first byte because the type data is there. So if it's channel data, it sends it to handle data, which we just saw. If it's a close, then we send the closed message back and we move it and we close this channel. If it's an EOF, then we call EOF on our pending buffer. Otherwise, we decode it, which basically is wrapping unmarshal and creating the type that's supposed to be passed in. So decoded is then a struct that we can then do a switch on. So if it's a open failure message, you can see in both cases it calls that thing to make sure it's the right inbound or outbound. If it's failure, we remove it. It seems interesting that it would pass. Oh, that's this message, yeah. I forget what's actually reading this, but if it's open is confirmed, it does some sanity checking, and then yeah, if it's an adjust, talks to the remote window structure. Close right, close. That's it. Now we have the helper stuff. Channel list is basically just a slice of channel objects. Index. So they actually don't, you know, I would have done like a map, but they actually do the an index in the slice, which is interesting. And so they have a mutex on it, and then basically some helper methods. So, you know, if you want to add a channel, this will find a place for it, basically looks for an empty place and puts it in there and returns the index. Otherwise, it appends it and returns the index. Get channel just looks it up, remove, sets it to nil, and then that means it'll be reused by add. Drop all is just clearing everything. Then we have that linked list buffer, which isn't that complicated. An element is some bytes and then a reference to the next one, and we have a head and a tail, and we've got a write, we've got EOF, we've got a read. So I'm not sure why this isn't like a bytes buffer. If I thought about it, I'm sure I could figure it out, but if anybody else knows, that would be helpful to know. And here's this window reference, right? Right to a channel. So this is keeping track of, I guess we have one for both local and remote, but basically whenever we get that window size change, we add to this. So it's just locking. It's basically just wrapping this uint window size and keeping track of whether it's closed and if there are right waiters. Is there a condition? Yeah, I guess there's a condition to close, reserve. This is what's actually going to block when you are trying to write more than is available in the window, and so this is what'll do the block on the right until it's available. I was curious because this isn't used at all. I was wondering if I could get rid of it, but it's used in the tests, and I haven't copied over the tests yet because I have to go through and see which tests are particular to this part of the library. But the rest is simple. You could probably get rid of these because I don't think they're reused that much. We have decode, which again just wraps unmarshal, having figured out what type of struct to pass in. Marshal is just you know, a switch on the struct, and then we write out the bytes based on that. Unmarshal is the reverse, and that's it. So, you know, it's 900 lines, and I thought it was, you know, like more complicated, and we might be able to simplify it more. My I'd love to simplify this as much as possible just so that it's easier as a reference implementation for porting to other languages. And some of this is going to change in JavaScript just because JavaScript is basically single-threaded, and so a lot of the type safety stuff I don't think we have to worry about. And so we might change how some of this works. Okay, so now all of this is kind of fresh in our heads. I don't actually write a lot of TypeScript, so was it like TX? I need a crash course in TypeScript. How about a quick start? No, none of this. Really, just like I want to write some TypeScript. Okay, so we've got it's a TS file. Blah 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 blah. So we might actually just start implementing the types that we're going to use because it's TypeScript and we can. So that seems like a good place to start in the interfaces. If anybody else has an opinion. Okay. So I'll just kind of start sketching things out. I guess we don't do any kind of imports or anything. Maybe we can do some constants. Do we have constants here? I guess JavaScript should, so. You can just do const, right? But we can't do any like iota stuff, so I guess we'll just manually do 101, 102, etc. That's just kind of being cute here with that, right? Might as well. This library, because we're doing binary encoding, we get to use, what was it called? I had to look this up. How do you do this in JavaScript? Doing binary encoding. Basically using the, I think the data view, and that'll do parsing different types. So I've not actually done this in JavaScript, but we will here. I'm going to man. I'm kind of like, I don't want to use, oh God, yeah, I guess. I was kind of in this group of people that were not writing semicolons in JavaScript, but is in the spirit of TypeScript, we would use them. So oops. And these are in order, so now, I assume we're gonna, I mean, might as well implement the same stuff here. You can actually kind of see how I was pulling code from different files because there's all these different constant definitions. but they are kind of different groups, so. Can you do this in JavaScript? Okay. I don't have this. I'm gonna do this implementation, see if we can get away with not having distraction stuff. And then I almost thought we could do this implementation, the Go one, without these structs, just because, sort of like, why not just encode, you know, stuff as you use them. It's actually kind of helpful to sort of do all the encoding and decoding in one place, and having the struct as a way to sort of have a nicer API. So I guess this is fine. I don't think TypeScript does anything fancier, or not fancier, but lighter. I mean, I guess we're looking for typed objects. Like, I don't want a class. I want like a struct. I think you can do like a typed object definition or something. Tuples, that's interesting. Yeah, I know you can do some kind of like anonymous type definition. Or maybe I'm thinking it should just be an interface. I think it would just be an interface. That's what I'm looking for. Because it's just an object that has these properties. And because interfaces in TypeScript let you define variables, or what do you call them? Properties. So I guess we'll do that. You probably let's see, a number. Do we want to store it as a number? I mean, they're just gonna I don't understand why Microsoft's documentation is so, like, it's thorough, but it, like, doesn't get to the point. Like, I just want the API. Where are the methods that I was just hearing about? This is a .NET data view. What the fuck am I doing? Here we go. So I'll be doing a lot of this. Yeah, I mean, I guess they're just stored as numbers. Does TypeScript have any, I guess they don't really care about, and they just model different numbers, yeah. All right. So I think we can do this. Ooh, that worked out pretty well. And then, what did it look like? Name and type. So really all of these can be number. What do I want to store this as? A string? What does WebSocket give us in its data? On data is just like a oh my god. Okay, what is it? Thanks. Thanks, JavaScript. Represents the data. I mean, if I recall, it's just a string, but I'm just wondering if it was anything else. Or could be anything else. I guess I'll be... Alright. What is it? Oh, because we need a colon after all of these? I guess we could do a quick test and see if this gives us anything interesting. Yeah, it doesn't really care about the interfaces because it's a compile type thing, but it does set all these variables. That's strange. I would have thought they would have used, I guess. Okay. It's fine. Alright, what next? You got these interfaces. Let's define these interfaces. Slightly more fun. Okay, interfaces with functions. Oh, you can actually define an interface for function type. That's cool. Alright, so this would look something like... and so we do this in callback form, so I think the convention is doing an error and then Unless I want to do, man. Someone was thinking the same thing I was. Okay, so we return a promise. I'm not familiar with like the promise, like how do you do errors with promises? Can you just like... I guess we know that we're working with promises now. Although I remember there's all kinds of implementations of promises. There is a native promise right now in ES6 or whatever. Blah 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 promise. Okay, I don't know how to use promises. I mean, I've used things like promises for ages, but everybody does different APIs. So we have resolve. Yeah, we've got then, resolve or reject. So I'm guessing reject is the error. Okay. 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 Okay, so that's cool. That kind of simplifies this. A little bit. Where was that page? TypeScript and promises. Yeah, callback style, blah, blah, blah. We're not going to do that. Mm-hmm. Mm-hmm. This is what I'm looking for. So, function that will return Fermi. Good question. I actually don't use it. This is called Dayboard. I used to use it. It lets you put in up to like 5 things that you're doing, and it's just a quick like, did you do it? Helps you stay on task. I have another system now, so I'll probably replace this. But it's pretty simple. I think it does some other features. Like I think it might bug you if you go to like a social website. I don't remember, but yeah, it's super neat. It's a great way to get started with that kind of like staying focused on 5 most important things to do. I used to use it a lot. Do you use anything like that, or what's your current method? Here we go. So yeah, it's just structure returns a type. Ugh. Okay, I'm just assuming this is gonna work. Promise of a channel. Yeah, I actually, so instead of using that, I use something called self-journal. It might be overkill for you, but it just happened to be everything that I wanted to do. Goal, targets, lessons learned, wins, gratitude, some planning. And it also has like kind of 3-month goal stuff as well. I've been using that for like a year. Maybe longer than a year now. This is basically the same thing. Close. See, we're gonna, I guess, translate stuff to exceptions. I don't think we have anything like this that we care about. In fact, like I said, our session in Go could have just been for read, write, closer, and so we wouldn't have those anyway. Wait is interesting because that's fairly Go idiomatic. Trying to think of something in JavaScript that would have the equivalent. I guess it would just be an event. And in fact, this would be an event. So how do you model events in TypeScript? Okay, this is... yeah, I guess it's... yeah. I guess I have to choose an API for events. Well. I guess this is the convention I kind of like. What's Node doing these days? Event emitter. They do on-off now, right? They do on-off and a bunch of other stuff. guess we'll just call it an event emitter. This is not type specific. Public logged in. Yeah, that's not exactly what I want. I don't really want to expose events that way. A little bit more like this. Forgot about this aspect. You make your own. So wait, they actually don't even specify the event name. That's actually event string. Alright, I'm gonna have to look at another library to see how they would do this. Like, what's a library that is written in TypeScript? These are all quite big. Yes. I like this. Okay, basically have to implement our own event system, huh? This is once, right? What is the point of disposable? Disposable listener. Oh, I see. So you could get an object back that would cancel the. That's actually pretty great. I don't think we need that. But I like this. And then we'll add disposable if we really need it. Oh, shit. So we would need an implementation. We'll leave the implementation because it's basically boilerplate stuff. We can do an event emitter later, but I want to see how this is used. Extends event emitter. All right, I guess we're gonna have to extend it. And then how are they? They don't seem to be defining their events. how about like a public thing? Like selection manager seems like a public thing. Private, private, private. Huh. Maybe that's not. That might not be related to their events that they're dispatching. Like I know they generate docs for this, so like how are they defining the events for this event emitter? You know? See, they have an activate, but they aren't. How would you know that it emits an activate event? I mean, I guess we don't have to document that. Oh, I'm getting some, here we go. Anybody have ideas here on, maybe this is a bad example then. If they're not documenting their events, I guess we can check their docs and see if event emitter, so okay. So at least for this class, they're doing this. And they do it for on, and then they have one for off that just has all of them. Yeah, this is what I think I understood as how you would model your event types in a system like this. Unless they codify them in any other way. I think they just say methods, properties, constructors. I think there's actually, if they're using doc type or whatever, there is something that will let you list events. I forget how to use that. We can do that later though. The main thing is this. So now, I guess I'm interested in does their add disposable listener also? Okay, it doesn't. So even though this takes all the same strings, they use on as the place to define all these variations. Okay, cool. We will do that. They do that function. Okay, it just doesn't show up in their thing, but they actually do define that specific. So we would do one for each thing. Let's see. Oh, because they have specific things, so we'll do. Oh yes, and we do return void. Okay, so what would we call this? On a, it's not accept on a new channel. God, what would this event be? In WebSocket, it's events open. Well, there's the open. I mean, if we're doing promises for open, I don't think we really need to do an event for it, but you know what? If we design this for async await, why not do this more traditionally and just have like an accept that returns a promise in a channel? Fuck all this event listener shit. I'm running out of time. Yeah, man. I'd rather just do fucking promises and shit. I mean, it's based on promises, so... blah, 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 blah. I mean, come on, you JavaScript. Fucking... No shit, async await blows it away. How would you use an async await accept? I guess you wrap it in something that you could then catch. Okay. We might end up, you know, changing our mind on this, but I think this is the way to go. I mean, maybe we also do events, but I mean, it's just so much more boilerplate to get events working. We'll close. Can you just say promise? Like we're just gonna wait for an event? Type promise. Probably, right? So, might change our minds, but and then this is where things get interesting. Do we? I mean, this is convention. This is like traditional read-write APIs. JavaScript has never done that before. Like maybe write, but they always do event-based stuff for read. So. This is interesting. What the fuck is this? Rename. Okay, now we're getting somewhere. Open. Okay, what the fuck? Promise for completion. To write to the file. We write, we get a promise. Aha, this is interesting. Here we go. This is interesting. Yes, yes. Yes, this is what I want. Read data from a file buffer is the buffer that they be written to. And what does their write look like? Returns a promise. Bytes written. See, they get it. They get it. Return to the traditional APIs once you get rid of this stupid event shit. Oh, I'm out of time. Well, I will put this here and come back to it. Maybe tomorrow? I think things will start speeding up because we're sort of defining the interfaces, right? So we're defining like how the implementation, you know, the definition of it. So this is the hard part in figuring out what's the idiomatic way to do things in the conversion. Otherwise, it's all much more straightforward, I think. So, yeah, this might be a 2-stream. Yeah, I might need at least 2 more hours to do this. So, but it'll probably also be unscheduled. So, but I'm probably gonna work on it. If not tomorrow, then Thursday. So, thanks for hanging out. Ask any questions if you're watching on YouTube. Let me know what you think of these streams. I guess I should do a recap real quick. See, we didn't get a whole lot done. It's more kind of research and prep stuff. So I won't do an official recap, but obviously I'll do kind of a lightweight thing. We're trying to port qmux to TypeScript to use in JavaScript, and so we're basically trying to go with a literal port of this Go implementation and figuring out how to do this in TypeScript. So we've got these interfaces for our structs that would just be objects, and played with the event emitter stuff, which we might come back to, but I think we're going to focus on promises because that lets us keep it a little bit closer to the original API while being a little bit more progressive on the JavaScript side. I don't know why this requires a type argument. Can I just do an empty thing or like void? That makes sense. So we're in the middle of that, kind of figuring out what the API is going to look like, and we've kind of settled on doing promises, and so now we just need to apply that to channel, which we're mostly referencing how Node does their promise-based file API. After that, though, I think we get into implementation, which should again be pretty similar, except maybe a little bit simpler because we don't have to deal with as much concurrency stuff. All right, so that's it. I'm going to be streaming some game development stuff in about an hour, and then later today we've got the scheduled Go Component Lab stream. So see you guys later.